Good day, everyone. Good day, everyone. My name is Witness Wurayai, and I'm going to be introducing on the topic numbers. We will be learning about different types of numbers as well as looking into factors, LCM, and reciprocals. Now, we'll start off with natural numbers. Natural numbers are positive whole numbers used for counting and ordering. They are known as counting numbers. So, for instance, if you're counting whole figures, or if you're counting a set of fingers, you'd say I have 1, 2, 3, 4, 5 fingers. If you're counting people in a room, you would say there are 1, 2, 3, 4, 5 people. You don't start by saying there is 0, 1, 2, 3 people. So the example of, for example, the number of students in a class is 28. So I think we were on natural numbers. The number of students in a class, say 28, is a natural number, and it starts from 1. It does not start from 0. Integers. Now, integers are all the whole numbers, including positive numbers, negative numbers, and 0. So when they say integers, without specifying whether positive or negative, you include negative numbers as well as positive numbers, including 0. Then they can talk about positive integers. These are the same as natural numbers. They will just start from 1 up until infinity. So where it says 1, 2, 3, those 3 dots mean and so on. Negative numbers. Negative numbers, we can have -1, -2. Let me go back there. -1, -2, and -3 up to infinity. So the temperature of -5 degrees is an integer. However, if it's -5.6, that's now a decimal number. The number 0 is also an integer, but if we say positive integers, we are only talking about positive numbers without 0. Negative integers, negative numbers without 0. But if they say integers, they are referring to all negative and positive integers, including 0. Proceeding, a prime number. So now we are on prime numbers, as you can see. Now, a prime number is a natural number greater than 1 that has exactly 2 distinct factors, 1 and itself. Moving on here, the first few prime numbers, for instance, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Now, you have to understand that prime numbers don't have any other number that divides into them besides 1 and themselves. So, in other words, they only have 2 factors. So, for instance, if you look at 2 over here only has 1 and 2 that divides into it. You see? And if I can go back there, if you have 3 only has 1 and itself, 1 and 3 that divides into it. If you have 29, there is no other number or no other numbers that get into 29 besides 1 and 29. 1 is not a prime number since it only has itself. We are talking about whole numbers that divide into 1. And 2 is the only even prime number. So 2 can double as a prime number as well as an even number and a factor of any other even number. Square numbers. Square numbers, a square number is a number obtained by multiplying an integer by itself. It is the number of multiplying an integer by itself. It is the result of multiplying an integer by itself. So if you talk about perfect squares, let's say if you say 1 times 1, you get 1, 2 times 2, you get 4, 3 times 3, you get 9, 4 times 4, you get 16, and if you say 9 times 9, you get 81. So if you say a number by itself, for instance, n squared, meaning n representing any integer, any whole number, then if you say 3 times 3, you get 9. For example, 9 times 9, which makes it 81, meaning 81 is a square number. Of course, you may have numbers that are decimal that are square, like you can have numbers that are in decimal form that are square. Like if you say 2,5 by 2,5, you get 6,25. But for in this instance, we're talking about whole numbers, whereby we get an integer multiplying by itself to get us a whole number, which is a square number again. Now, cube number, almost similar to square numbers, only that this time you are multiplying that number by itself 3 times. Some textbooks say by itself twice, like when you say 3 times 3 times 3. So they are not including the first 3. But here we're saying multiplying a number by itself 3 times. And where is the definition or formula? N to the power of 3. So when you say 2 times 2 times 2, what do you get? You get 8. If you say 4 times 4 times 4, what do you get? You get 64. And remember, or take note, that 64 is the only number, or is one of the few numbers that is a square and also a cube. I'm sure that there are also other numbers out there that are square and also a cube, but few. If you say 4 times 4 times 4, you get 64. But if you say 8 times 8, you also get 64. So, for example, 4 times 4 times 4 is equal to 64. So 64 is a cube number. Moving on to common factors. But first of all, we have to understand what a factor is. Now, a factors are numbers that are that divide exactly into another number without leaving a remainder. Factors are numbers that divide exactly into another number without leaving a remainder. For example, if you say 6 into 48, 6 will get into 48 8 whole times without leaving a remainder. Then common factors are factors that 2 or more numbers share. For example, 48 and 36 can share 6 as a common factor. 48 and 36 can share 12 as a common factor. Now, we have an example task. Find the HCF of 24 and 36. So all you have to do is to list all the factors of 24, the highest common factor. So when you're listing all factors of 24, I think you can refer to the videos on how to list factors of a number. So if you go back there, you'll see that factors of 24 start from 1 all the way to 24 itself. So remember, 1 is a factor of every number, and the number itself is a factor of itself. 36 also have factors of 36, 1, 2, 3, 4, 6, 9, 12, 18, and 36. Remember to watch the video on how to write factors of a number. And you can see that 12 is the biggest common factor that can get into 24 and 36. So common factors obviously of 24 and 36 are 1, 2, 3, 4, 6, and 12. But the HCF is 12. So finding factors of a number, highest common factor, and highest common factor prime factorization method are going to be listed, are going to be shown in the videos. So now we have multiples and LCM. A multiple is the result of multiplying a number by an integer. A multiple is the result of multiplying a number by an integer. Common multiples are multiples that 2 or more numbers share. The lowest common multiple is the smallest of these common multiples. So for instance, you've got 8 and 12. If you look at the times table, if you say multiple of 8, you get 8. 8 times 1 is 8, times 2 is 16, times 3 is 24, 32, 40, 48. And you will see that also for 12, 12 times 1, 12, times 2, 24, times 3, 36, times 4, 48, 60. And you see that maybe factors like 72 and 96 are common factors, common multiples of 8 and 12. But here we get to look at the lowest common multiple. So the common multiples are 24, 48. I believe we can get to 72, we can get to 96, and so on. So hence the common multiples of 8 and 12 are there: 24, 48, 72, 96. However, the lowest is 24. So hence videos for lowest common multiples will be shown in the link or playlist. Using the prime factorization will also be shown, and also a second example. Now I want to talk about rational numbers. Now, what is a rational number? A rational number is any number that can be written as a fraction, or like p over q or a over b, where p and q are integers and the q will not be 0. This includes all integers and terminating and recurring decimals. So for example, you have 5, which is a whole number, it's an integer. 0.75 is a terminating decimal, which can also be written as 3/4 a over b. Minus 2.5 is a terminating decimal. 1/3, a fraction, or which can be written as A over B or P over Q as illustrated. 0.33333 is a recurring decimal and can be written as a fraction 1/3. Irrational numbers obviously are the almost like opposite or what rational numbers aren't. Numbers that cannot be written as a simple fraction, their decimal representation goes on forever without repeating. Pi is one of the few irrational numbers which obviously its decimal cannot be will continue going on and on without repeating. Although in mathematics, for ease of calculation, especially non-calculator papers, pi can be written as 22/7, but that does not make it a rational number. Then also we've got the square root of a non-square number, or the square root of a number that is not a perfect square. So here in detail we have rational numbers. Rational numbers are whole numbers or integers, like they can be negative integers or positive integers, as you can see, from -10 all the way to 350. Rational numbers can be written as A over B, as a fraction, as a simple fraction, as a mixed fraction with a negative, as an improper fraction, or as a mixed fraction with a positive. They are terminating decimals, meaning that when you're writing the decimals, they come to an end. 1,75, 0,25, 3,62. It doesn't necessarily mean that the decimals have to be written to 2 decimal places. Even if it's written to 4 decimal places, 6 decimal places, as long as the decimals can terminate without being rounded off. And then square roots of square numbers. For instance, you have the square root of 100. 100 is a square number, therefore that makes the square root of 100 a rational number. So if you see a sign that is saying square root of 225, that's a rational number, because the square root of 225 will give you exactly 15. Rational numbers are also recurring numbers. So 1,22222 can be written as 11/9 or 1 and 2/9. 0,3333, meaning that this can be written as 1/3. 0,11111 hence can be written as 1/9. Irrational numbers. Now with irrational numbers we mentioned that they cannot be written as A over B. The decimals do not terminate and does not have a recurring sequence or a pattern, the decimals. So like for example, that number there, it goes on and on, there is no sequence about that number, and it does not terminate, and it goes on and on. Pi, I think it has been mentioned, is not a perfect square. So when you're looking for the square root of a non-square number, like the square root of 1000, the square root of 30, the square root of 200, it may appear like as if the numbers sound rational, but hence, as long as those numbers are not perfect squares, you will get a decimal that goes on and on and on. Okay. And even if we say, if there is such a thing as a perfect cube, if we are looking for a perfect cube, in other words, if you say the square root of the cube root of 1000, you will get 10. So obviously that will make that number a rational number. Now let's talk about reciprocal. The reciprocal is of a number is 1 divided by that number. When you multiply a number by its reciprocal, please take note that the result is 1. To find the reciprocal of a whole number, put 1 over it. For example, the reciprocal of 5 is now 1/5. To find the reciprocal of a fraction, you flip the fraction. For example, the reciprocal of 2/3 is 3/2. And hence, if you're going to multiply 2/3 multiplied by 3/2, you will see that the answer will be 1. And please do take note that 0 does not have a reciprocal. We will talk more about reciprocals in the videos to be added in the library. Thank you for watching. For more lessons, reach out on 777-992-527, or you can email tutor.academy@gmail.com. Please do take note that I do conduct face-to-face lessons in the heart of Bulawayo CBD. All you have to do is to contact me on that number. You can also visit our Facebook page, Tutor. The link will also be provided in the video, in the captions below. Thank you so much for watching. Subscribe onto our YouTube channel for more updates.